Okay, welcome back to chemistry prep station. We are still discussing gas laws. Please, I will try to add more speed to my discussion so that we can finish up. All right. So I want to take you on Boyle's law. So what is Boyle's law? Look at the screen very well. You can step Boyle's law using equation. Very simple. Okay. So P is inversely proportional, okay, to V. What does that mean? Okay. At constant what? Temperature. All right. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure, provided the temperature is constant. When you do that, you now have your PV is equals to K. What is your K? Your K is what? Is a sign of proportionality. With this, you now get your P1V1 equal to P2V2. All right. Let's move on. Now, this is a graph of what? Of Boyle's law. Okay, with respect to their various parameters, don't forget. All right, please watch the slide and see. The next one is a Charles law. Charles law is in Charles law, pressure is constant. All right, you can see from the equation here, T is proportional, directly proportional to what? To volume. So Charles law states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature, or you call it absolute temperature, provided pressure remain what? Constant. When you do that, V equals to T, okay, therefore our V1 over T2 is equals to V2 over T2. So this is what you use in solving your Charles law what problems. Let's move. Now this is also the graph for Charles law. Look at this very well. For minus 37 and above. So look at it very well. Sometimes they can sketch a graph for you and say which of these graphs signifies Charles law. All right. So general gas equation, where this law is gotten from Boyle's law and what? And also Charles law. How do we do that? No time to prove that. You want to prove that, consult your textbook and see how it's being proven. All right. So in general gas equation, we have P1V1 all over T1 equals to P2V2 all over T2. So the parameters are well labeled, all right? So look at the slide very well. Now look at, this is their various, okay, formulas regarding to what? To a general gas equation. From this one equation, you can see we can generate how many? We can generate 9 more equations. So general gas equation is very you must know it. You must know this law and now know how to generate other equations based on the question. So look at the slide very well, you will see that. Now let's take one example of this law. A balloon with helium has a volume of 50 liters, which is your volume, at 25 degrees Celsius. That is your temperature, and a pressure of 1.0 atm is atmosphere. What volume will it have at 0.855 atm and 10 degrees Celsius? Note, you will never use temperature in degrees Celsius while solving problem in gas laws. You must convert them to what? To Kelvin. How do you do that? Add it up to 273, which is your standard temperature of a gas. When you do that, it's on the screen. Substitute the value carefully. You will now know that your answer is what? Is 60. What are you looking for? What volume? You are given V1, so you are looking for V2. According to this question. So you must look at the option, the parameters carefully and look for what you are looking for and then carry out your correct substitutions and operation. You have your answer. The next one is your ideal gas equation. Take note of this relationship. With this, you can be asked to find 5 parameters. First of all is pressure, volume, number of molecules. This R is a constant anyway, and then temperature. So this is what they stand for, all right? And the value for R is 0.082053 and so on, all right? So this value, sometimes you may not be given in the question, you must know it. If you're lucky, you'll be given in the question, but know the relationship that PV equals to nRT for ideal gas equation. Okay, now that takes us to Graham's law of diffusion. This is where students find it so difficult. This is one of the difficult laws in gas laws. It's so confusing because these laws will give you 5 equations at the end of the day. All right. So this law states that the rate of diffusion of a gas at constant temperature and pressure is inversely proportional to the square root of its vapor density. That's why you have R is proportional to 1 over the square root of D. Okay, so here we have many equations though, so you have to be careful, must be careful how the equation comes and the kind of relationship you're supposed to use for the solving. So this is, you have equation 1 here, equation 2, we have equation 3 here, all right, with rate and time. We have equation 4 here with time and what and mass. Don't forget, others are inversely proportional, but when you come to time, time is directly proportional to mass or to density. Look at this. We have T2 over T1 equals to the square root of M2 over N1. So it's a direct proportionalism, unlike other that is inversely proportional. So this is where the question always comes from because of the confusion. Okay, when solving Graham's law, they always pick questions with regards to time and mass because students always confuse themselves while using this law. So at the course of this video, we're going to see some questions with regards to Graham's law and how to target it. These are all questions for Graham's law. The next law is Dalton's law of partial pressure. Now, this law simply means that all the partial pressures sum up to give us one pressure. All right, we have different gases coming together to give us what? One pressure at constant temperature and pressure. Now, look at this video very well. We have different gases here, right? We have oxygen, all right? Oxygen, nitrogen, argon, water, steam, that is steam, and CO2. Now, the sum of all these pressures, these are all partial pressures, right? Okay, all will now form air. This is the sum of the pressure. So this is what Dalton's law was trying to discuss. It says that the pressure of a gas is equal to the sum of all its components. Or you can say in this form, at constant volume, at constant temperature, the total pressure of a gas or mixture is the sum of the partial pressures or what of the gas present at constant temperature and pressure. All right, so let's move on to another law called what? Gay-Lussac's law of combining what? Volume. Now, this law states that when gas combine, they combine in simple whole ratio. Now, look at the equation given here. This is an example of what? Of Gay-Lussac. It has to do with volumes. Now, how many volume of nitrogen is needed to combine with hydrogen to give us ammonia? This is 1 is to what? 3. Okay? 1 volume is to 3 volume of hydrogen, giving us what? 2 volume of what? Of ammonia. So it was particularly concerned what? The volumes of gas when they are what? When they are in a particular chemical reaction. Totally, we have 3 volumes of hydrogen, okay, that will produce what? 2 volumes of ammonia. Equally, you can also say we have 1 volume of nitrogen that can react with what? 3 volumes of hydrogen to give us what? 2 volumes of what? Of ammonia. Now, this is another example regarding water, all right? So the slide will explain more. Okay, look at it very well and you understand the concept better. The next one is Avogadro's law. Equal volumes of gases at the same temperature and pressure contain equal number of what? Of molecules. This one has to do with moles. Don't forget, Avogadro has to do with moles, while Gay-Lussac has to do with volume, but they are one of the same thing. There's no more difference between two of them. Now, we have Avogadro's constants. Don't forget it. It is 2.02 times 10 to the power what? 23. All right. Now, you can also state Avogadro's law using this. V is proportional to N, in which N all over V is equals to K, and you have V1 over N1 equals to V2 over N2. You can tackle Avogadro's law using this relationship. The last one there in this law is relative vapor density. I'll move straight to equation, right? Now, this is equation for relative vapor density. Relative molecular mass all over 2, all right? So by definition, it's defined as the number of times a given volume of gas is as heavy as what? The same volume of hydrogen at the particular temperature and what? And pressure. That means that if a gas is less dense, all right? It's less dense than air, okay, what happened? It will be flying. But if it's denser than air, for example, now look at this very well. This is the vapor density of a gas, all right? Now, air is 1.0 by vapor density. Now, you can see now, hydrogen, okay, is greater than what? 1.0. That's why it's sinking. It's sink. It's not floating. Okay, you can see in the slide now. But methane here is less than 1. You can see methane is what? Is flowing. Because it's what? It is less dense than what? Than air. All right? Or sorry, it's dense, less dense than air. It can flow. All right. So, How do you solve it? Relative molecular mass over what? Over 2 give us what? Formula for vapor density. Now let's look at some few questions regards to this law. All right, there is a very broad topic. I'm just trying to summarize it. At the course of this video, you can consult your textbook for deep explanation. All right, example 1 says an increase in temperature causes an increase in pressure in the, what's the answer there? Number of collision between what? The molecules. If you increase the temperature, there's what? There's tendency to have what? High kinetic energy. All right, so the molecules of the gases will bombard with each other faster and also with the walls of the container. All right, this is example of Graham's law. Yes, this is where JAM always focus on because it's very confusing. Now look at this question. 200 cm cube of oxygen diffused through a porous block in 50 seconds. How long will 80 cm cube of methane take to diffuse through the same porous block under the same condition? Very good. Now, look at the question very well. Identify your parameters accordingly and carefully. All right. Now, in this question, you are given different volumes, but at the same time. But you have to find what? Find how long would the other mass, with the other, the time taken for the other, methane to get to diffuse. Now, you must know the molar masses of the compound if you're not given, but here you are given. All right. So now go back to the question. 200 cm cube of oxygen, that is your V1. That is your V1. You can also swap it anyway. But if your V1, let your V1 and T1 be the same. You cannot use V1 for oxygen and use T1 for methane. No, that's a wrong combination. All right? So place your work accordingly. 200 cm cube is your V2. Yes, that is your V2. Diffuse through a porous block in 50 seconds. That is your what? That is your T2 also. Don't forget. How long will 80 cm cube of methane take to diffuse through the same porous block under the same condition? So now you're looking for time for methane, all right, to diffuse through this different volume. Now, how do you do it? This is, you're using time, you're using what? Time to mass. You're using the equation of Graham law that involve time and what? And mass. So, but the time is not given directly. What do you do? Since rate equals to volume over time, all right? Volume over time. So now, how do you get your time, your rate here? Your rate 1 is volume, which is 200 over 50 times what? You now reverse it. You now have T over 80. You have, now what's the molar mass of methane? Very good. It's not given. Your methane is what? CH4. So atomic mass of hydrogen is 1. So 1 times 4 plus 12 give us our 16, as you can see on the screen here. 16 for methane, all right, CH4. Then 32 is 16 times 2, all right? So when you now do this, you square both sides. Okay, here we not square both sides because there are many approaches to solve this kind of question. You don't square both sides here, but what do? You cancel carefully, all right? If you cancel carefully, you now have T4 all over 20. Are we together? T4 over 20. Then what is the square root of 16 is 4. Then 32, there is no square root, you keep it. You are looking for time for methane. Are we together? So therefore, make your TCH4 the subject of the equation. You now have 80, how do you get 80? It's 20 times 4, cross multiply, all over root 32. You now have 14.14. Just go through the calculation very well. You understand what I'm trying to do here. If you do very well, your answer is 14 seconds, which is option C. All right. Next example, yes, very straightforward. What is the partial pressure of hydrogen gas collected over water at standard atmospheric pressure and 225 degrees Celsius if the saturated vapor pressure of water is 20 millimeter mercury? This one is a very straight question. Now the question is, what is the standard temperature? What is the standard pressure of a gas? 760. Now this gas was collected over water at 25 degrees Celsius. What do? Simply subtract the one that was collected over water minus the actual standard pressure of a gas. You get your answer right. So that will give us what? 760 minus 23, which is 737 mmHg. Answer here is option what? A. Okay, another example is if a gas occupies a container of volume 146 centimeter cube at 18 degrees Celsius and 0.971 atm, what will be its volume? Now, which law is this? You must identify the law because what is given. Now you are given almost everything here, all right? So the best law that suits this is combined gas equation. You are looking for what? You're looking for V2. So pick out the parameters very well. I've solved it already on the screen because of time, all right? Pick your parameter very well, okay? Now replace it in this general equation. Make your V2 what? Subject of equation. If you do that, your V2 becomes P1 V1 times T2 all over P2 T1. Substitute the value. If you do it properly, now you will get 133 CNQ, which is your A as your option. This is JAM question. I did not form this question. I pick it from JAM pass question. All right. Another example, this is another example of Graham's law of derivation. You can see this one still involves time and mass. So you must pay attention to that particular equation where it regards to Graham's law. That is where their target is. The equation that involves time and mass. Now, look at this question very well. If 90 cm cube of SO2 diffuse through a porous partition in 14 seconds, how long will it take the same volume of S2 to diffuse through the same partition under the same condition? Very simple. Look at the parameter. Look at your T1 and your T2 carefully to avoid mix-up. So here your T1 is sulfur 4 oxide. Sorry, sulfur 4 2 oxide. Okay, then your T2 is for what? Is for hydrogen sulfide. All right, when you find the molar mass of this, you have 34 and 64 because you're looking for what? TH2. Square both sides, cancel out what? The square roots and cross multiply. All right, if you do that, you're going to have 10. Carefully. So look at the solution very well. All right, and you get your answer accurately. So the answer here is what? Is option 10. All right, another example is there. Number 6, the volume occupied by 1.5 grams of gas STP is this. What is the relative molecular mass of the gas? All right, so here you must get the number of moles first, all right, before you now talk of the molar mass. It's not given. So how do you do it? If 1 mole at STP contains 22,400, what will be the number of moles for 500? So when you cross multiply this, you have, when you cross multiply, you have 0.02232. All right. Now, how do you find the molar mass? All right, is reactive mass over number of moles. That will give you 70.7 at the end. If you now round it up, now you will 71 grams. So your option here is what? Is D as the correct answer. Now this one is Boyle's law. All right. So what do you do? Look at the question very well. All right. Look at what is given. Now choose your equation appropriately. Then the next thing, look for what. Pay attention to the question and now identify what you are asked to find. Now make that particular word parameter the subject of equation. That is all you need to do. Then do your complete substitution. You have your answer. For example, example 7 is there on the slide. Look at it very well. You'll see that it's very, very simple to go about it. If you solve it, you will get B as your final answer. Then another example is a given quantity of gas occupies a volume of 228 cm cube at a pressure of 550 mmHg. What will be its volume at atmospheric pressure? This is still Boyle's law because they are asked to find what? The volume, and you are given pressure. You are given P1 and you are given what? P2. A given quantity of gas occupies this. You are given V1, all right, and you are given what? P2. When one is say at what will be its volume at atmospheric, that means that you are given the pressure indirectly because they are referring to the standard pressure of a gas, okay, which is 760 mmHg. Don't forget, this is a standard volume of a gas. We get to millimeter mercury. All right, so don't say I am not given. This statement means you are given pressure. All right, what will be its volume at atmospheric what pressure? They're referring to the standard what pressure of a gas. All right, so you're going to use Boyle's law to solve this problem. So your V1 is noticed, which is 228. Your P1 is this. All right, you're looking for what? V2. All right, so your P2 is your constant, yes, pressure. So make V2 subject of equation. You have this. Then when you multiply out, 225 Cn cube is your final answer, which is your B. Very simple. All right. Another example is there. All right. So before we get that, note that this law, because when I come back, I will now move to the next topic. This law is very simple. All right. So look at the screen very well. I'll profile solution to all the questions here, and the answers I've identified. This is under Graham's law of diffusion. Take your time, study it, pause the slide, look at the question, and look at how it is solved. Then this one is very simple. The answer is temperature, which of the following is a measure of average kinetic energy of the molecules. If you increase the temperature, you increase what? The kinetic energy of a gas. So the answer there is what is D. An increase in temperature causes an increase in the pressure of a gas in a fixed volume due to an increase in what? Number of collisions, okay, of the molecules and of the walls of it. Question 13 and 14 are almost the same. They just twist the question. It's almost the same question. All right. Then this is your assignment. Question 15. Studied it. All right. Look at what this is general gas equation. Look at how to solve it. If you solve it very well, your answer will be 1.88 dn cubed. That is your assignment. Please make sure you solve it. Then also this is under Dalton's law of partial pressure. So we're going to go on a little break. When we come back, you continue from here. Please just keep watching.